Section 1.3. This is another rather boring section full of vocabulary, I'm afraid, but can't be helped. We all have to be speaking the same language, the language of chemistry, which I like to call chemish. We can distinguish between two types of properties, physical properties and chemical properties. Physical properties can be observed without changing a substance into another substance. The boiling point, the density, the mass, the volume, the color. Is it a solid? Is it a liquid? Is it a gas? All those things are physical properties. I can look at it. I can determine it. I haven't changed anything. The chemical properties can only be observed when a substance becomes another substance. Can I burn it? That's a chemical property. Will it burn? Will it rust? Does it react with acid? Anything where the substance is changed in order for me to find it out, that's a chemical property. We can also distinguish between intensive properties and extensive properties. Intensive properties, it doesn't matter how much of the stuff you've got. Extensive properties depend on the amount. I always remember it as being internal things versus external things. So intensive properties are things like the boiling point. Doesn't matter how much water I have, it's still going to boil at 100 degrees Celsius. The color, it's going to be blue if I have a little bit or a lot of it. The density, all those things are intensive properties. Doesn't matter how much I have. On the other hand, something like its mass or its volume, that is going to depend on how much I have. That's an extensive property. Now we talked about physical and chemical properties. These are physical and chemical changes. A physical change is a change that doesn't change the composition of the substance. So I've changed its temperature. I've boiled it. I've frozen it. Everybody always thinks boiling and freezing and changing state like that is a chemical property, a chemical change. But it's not. It's a physical change. If I take my water, pour it in the ice cube tray, stick the ice cube tray in the freezer, pull it out later so I have ice, I still have H2O. I still have the same stuff. So that's a physical change. Even though something's changed, I still have the same stuff. A chemical change results in a new substance. If I burn a candle, I end up with carbon dioxide. The part of the candle that burned, it doesn't exist anymore as candle wax. If it's rusting, I no longer have iron, I have iron oxide. That's a chemical change. A chemical change is also called a chemical reaction. Whatever molecules or elements I had at the beginning, I have different ones at the end. Remember, a chemical reaction gives me a substance with different properties. The products, the stuff I have after the chemical reaction happened, have different properties than the reactants, the stuff I had at the beginning. That's how you know you have a chemical reaction happening. The stuff at the end has different properties than the stuff at the beginning. Now let's talk about separation of mixtures. Remember, a mixture is something where the things involved are not chemically bonded. Everything in a mixture retains its properties. So when you're separating a mixture, what you're relying on is the fact that all those things in the mixture have different physical properties. So for example, you could filter. You have a solid mixed with a liquid. A filter will separate your solid from your liquid. Now, if your solid is dissolved, that won't work. You pour salt water through filter paper, you're still going to have salt water on the bottom. What you need is a solid that hasn't dissolved in the liquid. So, sand in water, something like that. The sand doesn't dissolve in the water. So you pour the sand and water through, the water goes through the little holes in the filter, You've got sand up here. If your mixture is one of liquids, you can distill. This is a distillation apparatus. This is something that happens in organic chemistry all the time. If you go into any organic lab, they'll have plenty of distillations going all around the room. What you've got is your mixture right here in the original beaker. You're heating it up. One of the liquids in your solution, in your mixture, reaches its boiling point. So the gas comes up and starts heading down this long tube here. Now this long tube here is being cooled with cold water. See how that says cold water in, cold water out? There's water flowing around. It's not mixing with your substance, by the way. It's an outer tube and an inner tube, and your gas is in the inner tube. But that little inner tube is being cooled. So what was a gas is condensing into a liquid, and that liquid rolls by gravity through this tube and ends up in this flask. Then what you do is you take that flask away, you put another flask in, you heat this to the boiling point of your second liquid, and there it goes. That's how you separate a mixture of liquids, by distillation. Chromatography is another way of separating. Basically what you've got is, this is a very common experiment people do. You've got a black pen. The black ink is made up of several different colors of ink, so you put it in the solvent. The water, usually water, could be alcohol or something like that, travels up the piece of chromatography paper, and as it does, the different colors are attracted to the solvent and the paper in different ways, and that's what separates them. This particular picture is a picture of something called paper chromatography because it uses paper. There's actually liquid chromatography and gas chromatography also, which are big complicated instruments that we don't have here. But it's a very common way to separate things based on the fact that the substances in the mixture have different attractions to some substance or another.